1 with a bunch of zeros. Mean of 0, standard deviation of 1. And, as expected, we're above 95%. We're 0.985 if we round to 3 spots. So 98.5% of z-scores will be above or equal to negative 2.17. Okay. Next one, what about the probability that a z-score is greater than negative 2.42 and less than or equal to 1.2? Well, we can sketch that out. So we want to be above negative 2.42, so somewhere about there. And we want to be less than or equal to 1.2, so that would be somewhere about right there. So we want to be above this and below this, so that just means we want to be between those 2 points. The intersection between those two regions is this between spot. Okay, so what is this probability? And again, we'll use the normal CDF. We're finding a probability from a normal distribution. This one's more straightforward in the sense that we don't have to deal with the infinities. We're beginning at negative 2.42. We're ending at 1.2. The mean is 0. The standard deviation is 1. And we get 0.877. You can leave it as a decimal, or if you like percentages, you can turn it to a percent. Doesn't matter. Okay. So this last one's interesting, and maybe you have a question that you've seen from the previous ones. What do we do with the less thans and equals? What do we do with the greater thans? We're kind of treating them the same. We haven't really paid attention to that. So this last piece here, well, sort of the last one, says what's the probability that z is negative 1.5? Okay. Think about that for a second. What do you think the probability is? What's the chance that a z-score will be equal to negative 1.5? Well, let's find it, and let's see what the calculator says that it is. So we're finding a probability from a normal distribution, so we will use, again, normal CDF. This is the one we'll use most often, but not always. Where do we start? Well, we're starting at negative 1.5. Where do we end? Well, we're not going anywhere. We want to be exactly negative 1.5. So we're also going to end there. The mean is still 0. The standard deviation is still 1. So let's see what happens. You get a probability of 0. Does that make sense? Indeed it does. So here's kind of why this makes sense. What if I told you I'm thinking of a number from negative infinity to positive infinity? Let me think about it. Okay, I've got the number. Now you have to guess that number. What's the chance that you will guess the same number that I'm thinking if it's from negative infinity to positive infinity? Well, it's almost impossible. There's an infinite number of values that you could guess, and I have one of them. So if you like the mathematical stuff, the probability is not actually 0. It's just pretty much 0. The right answer is 1 over infinity. Now this is kind of undefined. It just means it's really, 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 really close to 0. It's some positive thing, but it's so small it's essentially meaningless. Okay. And in case you were wondering what the number that I was thinking of, it was the square root of pi over 3. So if you guessed that, good job. So one more example. What if we have a random variable, x, could be anything, we don't care, that follows a normal distribution with mean 10 and standard deviation 3. Here's some problems to solve. So pretty straightforward. We can go through these decently quickly. Here's the distribution of x. The mean is 10 and the standard deviation is 3. So we have 13, 16, 19, 7, 4, 1. And for the first one, we want to be between 7 and 13. Well, we don't have to use the calculator here, really, right? We can use the empirical rule. By the empirical rule, that said this is 68%. But we can use the calculator anyways. We would use normal CDF. Start at 7, end at 13, mean of 10, standard deviation of 3, and let's see what we get. Seven to 13, mean of 10, standard deviation of 3. There you go. You get 68% and some change. So really, it's 0.6803, roughly. Okay, so we've kind of verified one portion of the empirical rule. It's not really 68%. They rounded. It's actually a little bit above 68% within one standard deviation. Part 2, what's the probability that the random variable is bigger than 16? So we can sketch that out. So 16 is 2 standard deviations above the mean, and we want to be above that. So what the empirical rule says is within 2 standard deviations, so between 4 and 16 is 95%, which means below 4 and above 16 add up to 5%. So that means 2.5% is here, 2.5% is here. So by the empirical rule, this should be 2.5%. And we can verify that again. So we'll use normal CDF from 16 to positive infinity, mean of 10, standard deviation of 3. So 16 to infinity, mean of 10, standard deviation of 3. And you get a little less than 2.5. 0.0228, I guess we could call it. Which is 2.28%. So again, we're seeing that the empirical rule is just an approximation. It's not really exactly 95% within 2 standard deviations. It's actually a little bit more. And since it's a little bit more, this means that this section would be a little bit less than 2.5, which is why we end up with 2.28. Okay. So if you use the empirical rule, if you gave me answers of 68 and 2.5, that's fine. I kind of see what you were doing. But as you notice, if you wanted to be more specific, the normal CDF is a little bit different. So then lastly, it's kind of an odd question. Find little x such that the probability that your random variable is less than that little x is 0.05. So what this is saying is you have your normal distribution all of these values down here, these are your little x's. Those are the values of your random variable. And we're trying to find a little x. So we need some value on this axis. And what we know is the probability that we're below that value is 0.05. So basically this is saying, what's the 5th percentile? So that's going to be somewhere over here. And there should be 5% below that point. So since we have a probability and we're finding a score, we will use inverse normal. So we have 0.05 to the left, a mean of 10, and a standard deviation of 3. So that means our random variable will be a little bit bigger than 5, 5.07. Okay, so not too bad. These are the two types of problems you'll see with normal distributions. You'll either find a probability and use normal CDF, or you'll be given something like a percentile or some other probabilities, and you'll be asked to find a value of the random variable. In that case, you use inverse normal. And that's it for chapter 6. So normal distributions, they're not too bad to work with, and we'll use these, as I've mentioned before, I think, almost exclusively as we proceed through the semester. We'll see that many things can be modeled or can be approximated by a normal distribution. So we can use the normal CDF, we can use inverse normal, and we can answer all kinds of problems. So this is the end of chapter 6. Next week is spring break, so no lectures. You'll have an assignment over this. I think that's homework 10. So that will be due the Thursday after spring break, which I'm not sure what the date is offhand. Your exam is due tomorrow night. If you have questions, send me an email. We can set up some office hours or something, but still ask those questions. Talk to you later.